Hello, yes, I think now it's audible. I think it's working now. अभी आवाज आ रही है सबको? यस, ठीक है. सो विल गोना स्टार्ट विद द बेसिक्स. यहाँ पे सभी को हिंदी चलेगा या यू गाइस वांट मी टू टॉक इन इंग्लिश? ठीक है, हाँ जी, लेकिन क्या चीज़ के लिए, हिंदी के लिए कि इंग्लिश के लिए? Okay, so majority are saying English and Hindi, so I'm not sure कि किस में करें. So we'll mix the both of it, हिंदी and English also. If अगर किसी को इंग्लिश नहीं समझ में आ रहा तो हिंदी में हम दोबारा कर लेंगे. And if someone is not fluent with Hindi, we can do the English session also later. All right, ठीक है. So first of all, we'll go through the basics of Houdini, like what are the attributes, data types, and what are the different contexts. Okay, then we'll see a RBD project. Okay, which will look like this. This is the play blast, and this is the renders. Obviously, there is no lighting or composition or anything, and it's just a normal render. Take it. So like RBD session mein we'll learn about how to put materials and interior and exterior materials, and then we'll also see how to apply the motion blur and how to obviously make constraints and how to break the constraints, what is glue strength and everything like that. So obviously it is important that you know key attributes kya hai. Okay, make sure ki you understand what are attributes, and then all of this which I'll be teaching you in RBD. Okay, it's gonna be very easy, बहुत easy है ये चीज़. ठीक है, इसके लिए इम्पॉर्टेंट है कि आपको बेसिक्स आए. ठीक है, दैट इज़ द मोस्ट इम्पॉर्टेंट थिंग, दैट यू नो द बेसिक्स एंड ऑल ऑफ दिस कैन बी डन ईजिली. Okay, but before doing this, obviously we'll have to learn a little bit of attributes and data types and everything, the basics of Houdini. ठीक है, and we'll start with the basics first. देखो, मैं एकदम भारी इंग्लिश तो नहीं बोल रहा, एकदम नॉर्मल इंग्लिश ही है. ठीक है, तो होपफुली सभी को समझ में आ रहा हो, क्योंकि मेजॉरिटी ऐसा है कि लोगों को इंग्लिश चाहिए, तो मैं नॉर्मली ऐसे इंग्लिश हिंदी मिक्स करके बात कर रहा हूँ. सो होपफुली सबको समझ में ही आ रहा होगा. ठीक है, सो लेट्स स्टार्ट विद दिस. मैं इसको मिनिमाइज करता हूँ. We'll start with the operators first. Ki what are like different operators? I have already created this file which will explain to us that what are operators. Okay, the type of operators, like where we exactly work and what are the different contexts, because in Houdini there are different contexts and every context has their own purpose. Like for example, we are in the object level, so this is also a context. By context I mean the area of working, where you exactly work. Okay, so there are a lot of contexts where you can also comp or you can render or you can place materials or textures or things like that. So this is your basic, the first object context, which is called the obj network, the object level. Okay, this is where you'll put all your cameras, lighting, whatever you import. Basically this is where it's gonna be. okay, in this object level. If you are confused what exactly this level is called, तो आपको यहाँ ऊपर दिख जाएगा कि it is known as object level. Okay, so obj level or object level. And I'm sure you must have heard about SOP, ROP, DOP, POP, LOP, ये सारी चीज़ें. Okay, so it's basically operators only. जो पहला नाम है it's gonna be changed like S, P, D, and the last name which is OP, operators, it's gonna be the same for everything. Okay, so hope you guys like clear with object level. Okay, so this is the basic object level where you're gonna put everything. Now the main important level is the geo level. Okay, the second which you're going to talk about, which is the surface operator, SOP level, which is the inside of this boxes that you see. I consider this boxes as a box which we have at home. Okay, and the box can have different stuff at a time, like for example biscuits or chips or anything like that. So consider this box as that box at your home. ठीक है, घर पे जो आपका डब्बा है उसकी तरह इसको समझो कि इस डब्बे के अंदर सारी चीज़ें हो सकती है. इट कैन हैव एवरीथिंग. सो दिस इज़ अ जियो लेवल, द सरफेस ऑपरेटर्स. हाउ डू वी यूज़ इट? आई प्रेस टैब एंड आई टाइप जियो विच इज़ ज्योमेट्री एंड आई गो इनसाइड इसके अंदर. ठीक है, दिस इज़ माई ज्योमेट्री लेवल. यू कैन लाइक सी इट सेज ज्योमेट्री. ओके, and now I can do anything that I want in Houdini in this level. Basically any effects, destruction, fire, water, or modeling, or anything like that. Obviously there are more levels to it, but this is the basic where we'll place everything. Okay, सारी चीज़ें यहाँ पे रहेंगी default तरीके से. So this is a geo level and I can take anything from box to any DOP network, which we'll learn about this in some time. Okay, which is this DOP level. And obviously if you want the solvers, I can also get a solver here, Pyro solver. Okay, this is the solver. So everything that you want to work with in Houdini is gonna be at this level, geometry level. Okay, so hope you guys are clear with this. Let me know in the comments if you're understanding what exactly are the levels. Okay, so the next one would be particle operators, which is also known as POP network. So this is gonna be the same as the DOP network, spoiler alert. Okay, it's nothing different from the DOP network. It's just a template, a default node which will give you all the POP material networks automatically. Okay, if I'll show you the examples here, I'll again take a geo, which is my box. I'll go inside. I'll take a POP network. Okay, POP network is readily available here. If you see, this is a POP network and it says it's a DOP network. And if I also take a DOP network, this is also a DOP network. So what exactly is the difference between these two? Actually, there's no difference. If you see, there's no difference. This is just a template DOP network in which you'll get all the POP particle nodes automatically. Okay, a lazy way of working if I say. So this is the same. If I also take a POP network or DOP network, I can take POP solver here. Okay, I can also take a Pyro solver here. Also a flip solver, which is for water. Okay, like water is known as flip, Pyro is known as fire, and the other is RBD, which we will use in this masterclass later. RBD solver. This is not this one, but bullet solver. This is just a template. Bullet solver. Okay, this is for destruction. So these are all the solvers that we use in Houdini for realistic simulations for fire, destruction, water, or smoke, anything like that. Okay, but the only difference is in POP network you automatically get all the nodes placed and you can on the fly do everything easily. You don't have to put any nodes. This is basically for the beginners, that you should know exactly how the simulations are working or how you can place the DOP networks and everything. So this is the same, there's no difference. You can also put Pyro solver in POP network. I can also put flip solver in. Okay, so there's no difference. It's just a lazy way of working, and this is just a template. Basically, this is top network only, the same as this. Okay, so hope it's clear and there's no confusion between the two, that what exactly is pop solver and how it is different from the DOP network. But these both are same. It's just a default template which says DOP, but is pop network, because you are getting all the nodes by default. Okay, hoping everyone is clear with that, so I can move ahead. Same. Okay, I've already explained it to you, like what's the difference between pop and DOP. Then next is something that beginners are scared with. Okay, it's vector operators. It's called VOP. If I again go inside and take a VOP, if I press tab and type VOP, there are a lot of VOPs. If like, you can see VOP network, attribute VOP, point VOP, primitive VOP, vertex VOP, volume VOP. There are a lot of VOPs. Except for this volume VOP and heightful, these are different things. Okay, for attributes we only use all these VOPs. These are all the same. Okay, if I take a point VOP and then I can take a primitive VOP, I can take a vertex VOP, vertex VOP, and also a detail VOP. Okay, what is the detail name? Maybe attribute VOP. There's no detail VOP. Okay, everything is the same, the exact same how pop network and DOP network was same. Okay, the only difference is that here, if you can see the run over, if I take a point VOP, it runs on points. If I take a primitive VOP, it runs on primitives. If I take a normal attribute VOP, it is again on points, and the vertex VOP is on vertices. Okay, so same as the pop network and DOP network, there's no difference between all of this. It's the same. The only difference is lazy work, because if someone wants, I only want to work in primitives, so you can take a primitive VOP and it will run on primitives by default. But as usual, I can also change this to points and to vertices to details, and there's no difference. Okay, the interior of all these VOPs are the same. We have an input, we have an output. Okay, like normally I'll explain it to you that what's the difference and how to manipulate or calculate all this in between stuff, the data, which is scary. Okay, like not scary if you understand it. Primitive VOPs, attribute VOPs, everything is the same, so I suggest that you only take attribute VOP. If you want to work with attributes and you want to manipulate the data, attribute VOP is the VOP that will take. But there's no difference, you can also take all of this VOP and you can obviously change to whatever you want to work in, either points or primitives. That's the most part that we work in, is either points or primitives. Okay, we rarely work in details or vertices or numbers. Vertices we don't usually work in Houdini. Okay, that's very rare. The only thing that will work in most is points or primitives. Okay, so you can either take a point verb or the normal attribute verb, this, and the interior and the everything is the same. Okay, there's no difference. Hoping this was clear to everyone. If this is clear the difference, I'll explain it to you, like how to work on this and how to easily understand what exactly is going on. Because when you start working in VOP, there will be a lot of networks that you will be connecting, and it's essential that you know what exactly it is doing and what you are doing. The most important thing, right? So let me know if you have understood the differences. Please give me a thumbs up or like comment that you have understood. Amazing. Okay, so like you guys don't have any doubts, right? If you have any doubts, please let me know in the comments so we can clear it out right now before we move ahead for the basics. Okay, Now let's move ahead with the explanation of how exactly the VOP works, and later after this I'll also explain it to you like uh, what are VEX. But let's do one thing. We'll understand all the other context first, and then I'll explain it to you together, like what exactly is VOP and what is VEX, because both are similar. Okay, there's only one difference, so both of them are similar. So let's learn all the other context first. The next one would be ROP, the render operators, the place where you will put your render nodes and render everything. Okay, how do I go to that level? Basically, I know this is my object level. It also says object level here above, if you can see. If I left click it, okay, and hold it, I can see many other contexts like which we'll learn now. But the important thing is now out, which is a ROP network. Okay, it's called render operators, where we put the operators, the nodes of rendering. It's an out context. I'll now go to out, and it's blank and it says outputs. So how do I place a node which will render, right? I can press tab and write mantra. This is the only default renderer right now, okay, except for karma. That is a different thing. But inbuilt renderers, the like only which Houdini has is mantra. Okay, there's no other thing than this. You can obviously install third-party plugins like Arnold, Redshift, and V-Ray. Okay, and yeah, maybe all of this, Octane. So those are third-party renderers, but the default one that you get is mantra. And obviously this is a node where you'll place your render nodes, your cameras, what frames you want to render, if you have some extra passes that you want to render for comping, okay, and the objects, and obviously uh, shading, the limits, the pixel samples, noise sampling, and everything like that. And obviously there are information like render to disk, render to mplay, render to disk in background. There are many stuff that you can obviously explore. How do we save it, where to save it, what are the formats, and etc. Okay, that's a different thing. But this is the basic place out network where you will put all your render nodes, and you can render it to disk or in background, or simply there's also a render view here, same like the scene view. There's also a render view, which by default, if I press enter, let's say if it renders my text which we have put here. Yep, it does. Okay, so this is now rendering my text, and I can obviously right click and save the frames. And if you are doing it automated, you can obviously give a path here in the output picture, and you can put a camera, and then you can render to disk. So this will be saved in your disk. Okay, but it is working now, so I'll just cancel it. And obviously there are many rendering engines by default in mantra: ray tracing, PBR, which you know, okay, physically based rendering. So this was my out context. The next is COP, which is a composite operators. If you guys don't know, we can also do compositions in Houdini, and it is very much similar to Nuke, but not exactly Nuke, because Nuke is a completely compositing based software. But to one extent you can do a very good comp in Houdini itself. Okay, so how do we get the compositing network? As usual, go to this object, okay, left click and press, and there's a image, img. This is a COP network, which is compositing area. Okay, I'll go to this image. It says compositing network. So this is where we'll do all the compositing work. Same as Geo, I'll have to enter one image network here, image, and you can put anything like shuffle, add, and grade, color. Okay, anything. If you're familiar with Nuke or compositing, you can put the same nodes here, and you can do your own composition here. Okay, like do the effects, do the rendering, and then composite here. You don't need Nuke if you're not much into composition, or you don't want to do that heavy compositing. You can do the basic one here in Houdini itself. Okay, so this was our image network, which is your compositing operators. And the next one is chop. Similarly, I can go to the ch. This is basically for motion graphics, that you want to have a waveform or want to work with some sound waves or similar to animations basically. Okay, so you can work here in channel networks. And then the next one is VEX. So we'll discuss it together, VEX and VOP, moving forward. Shop, top and LOP, these are the last ones that we can see. ठीक है, तो यहाँ पे the shop is not used now. It is the oldest way of shading. Okay, so basically previously when Houdini was not UI friendly, this is where we used to composite or compute all the lighting and all the shaders basically, but this is not used today. Now we have the material network, so you don't use shop network, so don't get confused between shop and materials. Most of the tutorials, if you watch before 2016 or 15, they will be using shop for the materials, but today we don't use the shop network, we use the material network. Okay, because this is easy and you don't have to compute everything by default. So if I go to material network and I'll press principal shader, I'll get a shader which I can use for my shading of materials. I can place the textures whatever I want, any textures that I want, any bump or normals that I want, opacity and surface, base colors and everything, transparency. So this is where I will do that. Okay, but in shop network I have to make what we say, a shader basically. Okay, material shader builder, and then you'll have to compute everything, like compute lighting, because it won't be computing automatically. You'll have to place all the materials here and you have to tell that what exactly you want. If you know, like guys know about Fresnel and offset and color. Okay, so you'll have to connect everything and do it automatically here, but this is not suggested right now because this is an old method. If you obviously want to explore, you can, but the easiest way is using this material node. Okay, hope this is clear with you guys. And the next one is top and lob. These are the new additions to Houdini. It didn't existed like by like Houdini 18.5 or 19. It was the new addition, top and lob. Top is basically your automations. Okay, if you want to automate your caches or rendering or stuff like that, you can go to this task operators. Okay, this is where you'll do all the automated tasks. For example, if you want to create a wedge, okay, this is your scheduler, I can create wedges here. Obviously there's a different option also that you can also create a wedge here in the out network, but this is the oldest method that we used to use. But now we'll use this wedge in task, which is the automated place, and you can obviously place what values you want to wedge or make iterations. Basically, if you're not familiar with wedges or iterations, it is a very good way to automate your task. For example, imagine I have a explosion, okay, and I want to use different values there, but I don't have to wait that if I place dissipation at 5, what exactly happens when I have dissipation at 5, and then what exactly happens when I have dissipation of 7. So rather than waiting for the whole simulation to get complete and then you wait, then you again change the values and then you wait, so you can do all the tasks automatically. Okay, I'll create wedges, 5 wedges, 6 wedges, basically 5 versions of dissipation, that if one dissipation is there, then how the smoke will look, and if there's 5 dissipation, how the smoke will look. It will be all automated. You can place the values here, you can tell it to cache it, then it will render it. It will also make a play blast, and it will also save with the numbers and values and text and everything. So this is very easy and convenient way of working, rather than waiting for the whole night or whole day that if I do one simulation, how it's gonna be, and stuff like that. So this part is very easy for you if you understand wedging. Okay, and if I again go to object level, and the next is LOP, lighting operators, which is a stage level here. This is for the latest editions of Karma, USD pipeline, Solaris, whatever you can call it. Okay, obviously the Karma is like Karma renderer is still in still it like not in production, it still has bugs, but it is being fixed by 20 or 20.5 versions. Karma is the latest renderer of Houdini, which can work in both CPU and GPU graphic cards. If you have a good graphic card, then you can make use of Karma, and if you don't, you should still stick at Mantra, because we do use Mantra in the industry, and Karma is being used, but it is a slow process right now because it's not stable. So you can obviously learn Karma because it is super fast, and the USD pipeline, it is super easy if you understand exactly what is happening, and it's a universal data set. The USD pipeline, basically it will work with every software that you'll use, either Max, Maya, Unreal, Unity, Houdini. Okay, the USD pipeline is very easy, and it can make use of large data, like the calculations are too smooth and not laggy, basically not heavy. Okay, so it's easy if you understand what exactly is stage and how to use or render with Karmas. Okay, so these were the contexts that we use in Houdini, hoping that this was very clear to you guys. Please let me know in the comments that everything was clear to you guys, then we can move forward with Vex and VOP. I can't see your guys likes and the heart reactions. Please type yes if you have understood so I can move forward. Yes, okay. Okay, now the most important thing, let's understand the difference between Vex and VOPs. Okay, so what exactly is Vex and VOP? Because most of the time, students basically are not clear about how to work in either Vex or VOP, and the most important thing is that they don't understand that what is the exact difference between them both. So I will clear it to you guys, what's the actual difference and where to use what, either use Vex or VOP or anything like that. Okay, so let's make it easy for you guys so that you're not scared of how to use Vex and VOPs. I'll take a basic grid here, a normal plane, okay, a ground plane like this. Okay, this is a basic plane. Now I'll take one attribute VOP. Okay, let's go inside the attribute VOP. This is where we will manipulate the data. Okay, working in attributes or working with datas in Houdini is very essential, because Houdini is all about data. Okay, everything that you see has data, has values, and is important. So for example, it is not possible completely that you can do all the effects or all the calculations or all the manipulations through nodes in the geometry context. Okay, so at some point of your time you will need to use attribute VOPs or Vex. Okay, there's a difference between them two, but it is very easy and convenient, so let me tell you about it. This is my data. Okay, this has some positions. Okay, the most important thing that we'll have in Houdini is this capital P, which is positions. Okay, these are three float vectors, three floats data type. We'll learn about it right now, but don't pay attention to this. Okay, I'll explain it to you later, but this is the most important thing, that you have datas, and where you can see all the data is here, geometry spreadsheet. I suggest that you put your geometry spreadsheet here so you can see how your data is flowing and what exactly is working or not. Okay, so this is my grid. These are some positions. As you can see, these are some points. Basically I have 100 points and I have a position. Every point is existing at some position in the 3D space. Okay, imagine this 3D space and all the points. If you can see, these are points and these are like somewhere in the 3D space. Okay, and this is exactly what I want to manipulate in attribute VOPs. Attribute VOPs are for manipulating the data, that something exists but I want to add, subtract, do something else with it and then give it back to the original position. Okay, That's the basic thing of attribute VOPs, that you take some data, some values, you do some manipulation and you give it back to the original position. Okay, that is the main concept of VOPs. Now how do I know what exactly is data and how do I take that data from? There are 4 inputs here. This is 0, 1, 2, 3, 4. Okay, first input is what the data is calculated from. If I go inside, this is my input and this is my output. Okay, this is my input. I have positions, velocity, force, age, life, ID, color, UV. These are the different things that you can obviously explore. There are a lot of stuff here that you can import. Okay, I now want only position, which is P. Okay, we saw here we do have P, capital P. Okay, this is an attribute which you cannot delete. We'll talk about attributes and data types and all of this stuff. Okay, after we understand what exactly is the difference between VOP and VEX. Okay, so this is what I want to manipulate. What I want is, I want to push this positions, this grid to Y, like positive Y, either 1 or 2 or 3, whatever. Okay, so if you can see, the position Y is 0 here right now. I want that my position Y should go in 1 or 2 meters. Okay, whatever we do in Houdini is in meters. Okay, so like if you are working with Maya or Max, they have different units, but in Houdini we use meters. This one box is 1 meter. Okay, 0.1 meter, basically this is 1 meter, sorry. Okay, this is 1 meter grid and this is obviously 0.1, 2, 3, 4, 5, like that. Okay, so I want my position to be going up in the Y direction. What I can do is, I will take the position, and as I said, I want to give it back to the position and do something in between. I'll take the position, I'll give it back to the position. Okay, now whatever I need to do, I will do it here, the data manipulation thing. Okay, position has gone back to position. This is my input, this is my output, P, and I've given P. Now I want to put this up. So what exactly do I need? I need a value, okay, which will push this grid above. I will put a add, because obviously I want to add to this position so it goes up, right? Hoping that it makes sense. I'll put this add in between here, but still it does nothing. I have taken a position, I have added it, and I have given it back to the original position, but it's still doing nothing. Like, can anyone tell me why it's not happening? Okay, never mind. Because we don't have a value here. Okay, I am taking the original position, I have added a add node and I'm giving it back to the original position, but there's no value. So Houdini does not know what exactly needs to be done with this add, because obviously I need a value that can, you know, push forward or push above my grid. So what I can do is, there are number of ways to put a value here. The most common used technique is that I middle click this 0 or circle that you see here in the second input. I'll middle click here and I'll do a constant. I'll take a constant, okay, constant value, and this will give me a constant value which says that you can add any values here. Okay, so these are basically to add values, nothing else. Okay, it's just a constant value, as the name suggests, that you just put a value here. And this is my 3 vectors. Okay, I'll explain to you what 3 vectors are, but I know this is a 3 vector because it is a position, py, pz, px. Okay, obviously because position exists in 3D space, so it will have 3 axes, x, y, z, and it's a vector. Okay, I'll explain to you what a vector or float is. So I'll just take 3 vectors, and now I have x, y, and z. I'll put any values here, which is basically 2. So now you can see, as I put the value 2 here, which was 0 previously, and I press 2, it has gone up to 2 meters above. Now you can see the grid is in the air, okay, 2 meters above, which was on 0. You can see the values change here, okay, in p and y, like position y 2, and now everything in y is 2. The positions of y is 2 basically. Okay, hoping this made sense, that obviously this is not going to be this easy, but I just wanted to make sure that you understand how the data is flowing. Basically the only concept for VOP is that you have any data that is incoming, the inputs from whatever objects that you have inputted here, okay, in the first input. Obviously there are ways to import this second level, third level, fourth level, okay, but the only default way to work is that you put this on the 0 level, which this is 0 1 2 3 4, okay, and it will automatically have this values like p, v, if it exists obviously. Okay, if I do something with force, the velocity, age, it will not work. I can obviously create new values from here, but I don't have any inputs, like I don't have existing values for velocity, force, age. How do I note that? Because I don't have any attributes here, name as p or like v, f, id, age, right? I only have p here, so I can work in p. I've added it to some value and given it to the position back again. What if I don't give it to the position back again? See, it's not gonna work, okay, because obviously we are adding to the original position, so we have to give it back to the original position that we took 0 from here, we added 2 to the y, and then it is going back to the original position. Okay, hope it made sense to everyone. So obviously we are not gonna go like in depth of the warp working. Okay, the only difference is that you need to explore the things right. The basic concept is this only, that you have an input, you do some data manipulation and you give it back to the output. Okay, but what if I don't have the output that I need? For example, there are a way lot of inputs here, but I don't have any output here. So there are ways to export all the values that you have the inputs from. That's a different thing. Okay, but you can also do that, so that's not a problem. Okay, so if I talk about the difference between VOP and VEX, VOP is basically VEX only. Okay, if you can read it here, it says VEX builder, right? It is coding only, but this is a visual representation of the codes, meaning that you can see exactly what is working and how it is working, and it wants you to place nodes so it works. Okay, so this is a visual representation of the code. If I show it to you, right click VEX and VOP, view VEX code. Not all of this. Okay, the only last thing, it says sum, meaning total of something, p1 plus input 2. Okay, p1 meaning the position and input 2, the input 2 that we gave it here. If I show it to you again, this input 2. Okay, it says the sum meaning the total of something like position and input 2. Okay, this is a VEX code that is being worked, and obviously these are nodes, so you don't have to worry about the VEX codes, but this is VEX only. Okay, but this is a visual representation of that. Now what if I want to do the same thing in VEX? Okay, so I'll take a attribute wrangle. Okay, the only node that will use for coding for VEX. Okay, if you guys are into coding, then you should definitely learn VEX because it is faster and obviously it's a code. So whatever you can do here in 10 nodes, you can do the same with node like codes here. Okay, so like how do we proceed? This is based on C. Okay, C language in coding in IT, if you know. Same thing, we'll approach it here. Okay, the same way that we have a sum of something and that's the total. Okay, some for some values, right? So how do we proceed? I'll call @p. @p meaning that I'm calling the position. Whenever you want to call any attributes or data in Houdini, you will do a at the rate. Okay, you'll always write a at the rate, and then you'll call the attributes, which is at the rate p. And what axis do I want to work in? Okay, I obviously want to work in y, so what I can do is at the rate p dot y. Now I have called at the rate p dot y. Okay, and same what we did, I'll do a equals to at the rate p dot y. Okay, it's the same as the VOP. Okay, I took a position, I gave it back to the position. Now I will add some value to it. Okay, for example, plus 2. So what I did was I created a like attribute, not created, basically it existed, at the rate p, which is position of the y-axis, okay, equals to at the rate p, same that we're giving it back to the values, plus 2. Okay, and whenever in Bex, if you are like done with your code and you want it to get completed and read, you'll always put a semicolon at the end. Okay, if you don't put a semicolon and you will be like, the code is correct and I want to work, why is it not showing, or something like that, it will give an error because Houdini wants you to complete the code with a semicolon. Okay, now I can see it's the same, that my grid was on 0 and it's on 2 now, same as this. Okay, this was also on 2, this is also in 2, there's no difference. Okay, same, that p dot y, this is my final value. What I'm doing is I'm taking the position of the y and adding 2 to it, meaning 2 meters to it, right? Hope it did make sense to everyone. Please give me a thumbs up or say yes if you understood all of this. I tried to make it very easy. Okay, cool. Should we move forward? Now, these were the basics. Maybe you might have got confused, like what is data, what is float, what is vectors, and what are the positions, what is a p attribute or something like that. Now we'll try to understand what exactly are attributes and what are data types, and things like that. So you are not completely abandoned that you don't know, don't understand. So I'll make it easy for you guys, like what exactly is the working. Okay, so let's understand how attributes are, what attributes are basically, and how it works. नॉइज लाइक किस चीज़ में, वॉप में या वेक्स में? बिकॉज ऑनेस्टली हम लोग वेक्स में नॉइज़ इतना ज़्यादा नहीं बनाते, बिकॉज आई हैव टू राइट ऑल द कॉल नॉइज़ एंड फिर आपको 4-5 डेटा देना पड़ेगा. सो इट्स ईजी डैट यू डू इट ईयर. ओके, सेम आउटपुट 2 के बदले मैं एक टर्बुलेंट नॉइज़ लूँगा. आई टेक अ टर्बुलेंट नॉइज़ इफ आई वांट टू पुट अ नॉइज़ ईयर. I'll take the original position to this position, I'll add it to second value, and now I have a noise. Okay, obviously I cannot see the noise because I don't have much details here in the grid. So if I increase the detail, for example 100 and 100, now I can see that I have noise or basic turbulent noise. I can increase the frequency or decrease the frequency. Okay, this is the amplitude. So this is how you can put a noise. Same, you'll have to do a position, add that to the original position, and obviously it's the same. Instead of a constant value, now I have a noise. Okay, so this is how you can give noise to it. Now let's understand what attributes are and what are the data types. Okay, so let me just copy the examples here from my previous file. Okay, now let's understand what exactly are attributes. Attributes are basically characteristics or traits of anything. Okay, for example, if I'll tell you about a person, we meet someone and we talk to them, like what exactly is their name, what is the height, what phone they are using, what is their age, what color of shirt are they wearing, right, what is their phone model, and things like that, which is basically the characteristics of that person, which defines that person, right? So basically that are attributes. In Houdini, attributes are the most important thing because obviously attributes carry values. Okay, for example, if I take my name Arjun, okay, it's an attribute to me because it defines my name. Okay, so obviously in Houdini it's the same, that you have an attribute, it has a value, and then you work on it. Everything is that. Okay, whatever thing you do, even if it's flip solvers or pyro solvers, destruction or texturing, lighting, whatever it is, you'll always have attributes and a value. Okay, one attribute, one value. So basically attributes are something that is defining what the thing is doing, or what exactly it is, and where it is, and what is the value of it. Okay, for example, I've given a example of pav bhaji here. If you guys know what a pav bhaji is, right, in India we do know what a pav bhaji is. Basically it's a bread and some vegetables that we make. So bread and bhaji are some attributes. Ingredients, like what exactly that bhaji has, it has potato, tomato, onions. Okay, and where exactly is the bhaji, that is considered as a position. Okay, the characteristics of the bhaji, it is red in color, the pav is golden brown, right? So all of these are attributes. The most important attribute that we have is P, the position that we saw here, P. Okay, so this will always be there, it's not gonna go. The rest of them are like color. If I place a color here, okay, now I will place a color, like for example red, do a red. Now I have a new attribute which is called CD, color diffuse. Okay, RGB, if you guys know what RGB is, RGB. Okay, now I have a new attribute which is RGB, like CD basically. And if I want to create another, which is, I'll take a node facet, don't worry about this node, this just computes the normals. Okay, now again I have a new value which is called NXYZ. Okay, now I'll take another one which is trail. Obviously I don't have a velocity here, but I have a new attribute which is called V. So some of the attributes are known to Houdini as default. For example, as humans also, we do have some characteristics and data that exist like since the time we took birth. Okay, for example, obviously our names, or whatever it is. Okay, some values are there, and some values I can delete. I can make new attributes. Basically I can learn new things as a human. I can also delete all my bad habits and can adapt to good habits. It's the same with Houdini. Okay, I can create new attributes, I can work with the latest attributes, I can also delete the attributes. For example, if I don't want all of these attributes, I can place a attribute delete, and I'll delete the attributes that I don't want. For example, I don't want the color attribute, so I can delete the color attribute. See, the color attribute does not exist here. Even in geometry spreadsheet it does not exist. Okay, and if I don't want the velocity, the velocity is gone. Now only have P and N. This P data I cannot delete it. Okay, even though there's an option here to delete P, I cannot delete P. Okay, because P is the most important thing that we have, because it is telling me where exactly the points are in the 3D space. Imagine if I delete the P here, anything that I do will not exist only because I have deleted everything. Okay, if I don't have the points that are existing in the 3D space, there will be nothing here, right? So I cannot delete the P attribute, not like this, not with vex, not with VOP. Okay, the P attribute will always stay here, right? So hope you guys clear with this attributes. So there is a list of attributes that Houdini knows by default, and obviously you can create your own attributes. Okay, there's a node which is attribute create. So you can create your own attributes here. For example, I type here VfxBoi, and now it has a, I will just delete all of this. Okay, now I have an attribute which is called VfxBoi and it has 0 value. So I can also do 1, so it has a value of 1. Okay, and there are types, data types, we'll learn about it right now. Float, integers, vectors and string. These are the 4 main types of data that we work with. Obviously there are more, there are matrix, there are quaternions and everything, matrix 3, matrix 4, matrix 8. So that's a individual thing, that's an advanced thing. If you want to understand about that, matrix and quaternions, that's a different thing. But the most important basic data that we use is float, vectors, integers and string. This is the most basic data types that we use. Okay, so hope you guys are clear with the defaults and the attributes, like what exactly are the attributes. Okay, so we'll move forward. We'll now learn about data types. As said, there are only 4 types of data that we are going to use extensively in Houdini. Okay, let me create a sphere here first. I have a normal sphere. Okay, it's in 0 grid, and you can see by default it has a P attribute which is for position of where the points are existing. Okay, position X, position Y, position Z. Now there are 4 types of data that we can create. I'll take an attribute create here, not cast, attribute create. Okay, first data type that we see is float data. Okay, so I'll type float here because the attribute should be named float for your convenience. Like it should not exactly have to be named float, but for your own understanding. Okay, so I've named it float here. In type you can see it's float only and the value is 0, so I will give it a value of 1. So float are the type of data which is in decimals. Okay, like 1.0, 1.5, 10.2, 0.01, 100.2, 100.37, 1000.825, something which is in decimals, which has a point. Okay, and it has values. So these are float values. Okay, it cannot be whole numbers, it will always have a decimal, it will always have point numbers here. Okay, so these are the float datas. The second is integers. Okay, I'll name it integer here, so you know this is integer. Now as soon as I type integer, this is just a name that I'm giving to the attribute, but it is still in decimals, so I have to change the type from float to integers. Now we can see it's just 0. If I press 1, it's just a whole number 1. If I press 10, it's 10. If I press 100, it's 100. If I do 100.35, see there is no 0.35 because it is rounding up. If I press 5.5, obviously the number is above 5, so it is rounding up to the next number, which is 101. Okay, so these are integer values, it will never be in decimals, it will be in whole numbers only. Okay, so these are integers. Next is vectors. I'll write vector here and change it to vector. Now as you can see, vector, we have 3 datas now. Till now we only have had a single values. In float also there's a single value, in integer also there's a single value, right? But in vectors we have 3 datas, x, y, z, because in vectors we calculate 3 datas. For example, positions also, if you see, it is in vectors only, x, y, z. So whenever you want to work with axis or 3 values, you'll always take a vector. Obviously you can take 3 floats and do the same thing, because vectors are also known as 3 floats. Why 3 floats? Because if you see, vectors also have decimal values, 0, 0.0, 0, 0.0, 0, 0.0. If I press 1, 1.0, 2.0, 3.0. Okay, these are also in decimals. So here I do not have float, 3 floats, but it is also known as 3 float vectors or vectors. Okay, so this is a third type of data. Anything with 3 axes, x, y, z, okay, you'll always take a vector, or you'll always have a vector. The last is string. Okay, I'll name it string and also change it to string here. String is nothing but a name. Okay, anything that is related to characters, symbols, numbers, or whatever, it's just a name value. Okay, it's not a value, it's just a name. For example, if I give a name here, VfxBoi, see, there's a string attribute which is called VfxBoi. Okay, even if I give it a number, it still will count as a name, not as an attribute. The name is 12, it's not a value, so I cannot use it as a value anywhere. Okay, I can use it as a name. So string attributes are only name for characters, for symbols, whatever it is. If you want to name something, you'll use a string attribute. Okay, hoping all of this was clear to you guys. Please let me know if this was clear, and if you have any doubts, we'll wait for 5 minutes. You can take a break and then we'll start the RBD session. If you don't have any doubts in all of this, like basics and default what we have learned till now, we can obviously carry forward with the RBD and you'll easily understand what exactly is going on. Obviously RBD has different stuff, but the basic working is like this only for attributes and nodes and everything. Okay, so if you have any doubts, please let me know. We'll take a 5-minute break and then we'll continue with the RBD. Please write it in the comments if you have any doubts. No one has any doubts. For those who are like not beginners, I must have bored you in the first half with all the basics and everything, but I had to do it. But now you can call your friends back if you are only interested in RBDs. Okay, chalo everyone. Hope you guys are back with your breaks. We'll start with the RBD session that you guys have been waiting for. Okay, so please come back to your screens. So, how do you guys want me to help you understand this? Should I like do a walkthrough because I already have a file available here that I've done, or do you want me to do it from scratch? Because obviously, doing it from scratch will take a lot of time. Not a lot of time. We can do it fast, but what are you more comfortable with? Come on, guys, start typing in the comment section. Don't be so dead. What do you guys like want me to do? लाइक मैं पूछ रहा हूँ कि आप लोग चाहते हो मैं शुरू से बना के सारी चीज़ें दिखाऊं, क्योंकि उसमें थोड़ा सा टाइम लगेगा अगर मैं एक एक चीज़ लाइक डाल के चीज़ें करूँगा, और जो ऑलरेडी मैंने फाइल बनाया उसको मैं एज अ वॉक थ्रू यूज़ करूँ एंड आपको चीज़ें समझाओ कि व्हाट इज़ हैपनिंग। सो ये मैं पूछ रहा हूँ कि आप लोग को क्या चलेगा वैसे। I cannot do it in both ways, obviously I'll have to do it one way. Okay, walkthrough would be fine with people. So we'll save a little time. Okay. And I'll explain to you in detail, obviously. So don't worry about it. And obviously, I can also make it quickly and show it to you. But let's see. Okay, hoping everyone is back and we'll start. So, what exactly is RBD? Okay, the full form for RBD is rigid body dynamics. Okay, rigid body as in something which is very rigid. Okay, rigid as in like something which is not breaking yet and we have to break it. Okay, and dynamics, obviously simulations. Dynamics is a different thing. Dynamics meaning that something which has force or gravity, external internal force or whatever it is, and it moves to that force. Okay, these are called dynamics. And RBD, as we all know, have a lot of stuff. Basically layer wise we work on that, like we have normal fracturing, then we have debris, then we have dust, then we have grit. Grit is basically the small chunks or particles that you see when anything breaks. Okay, for example, here I don't think I have much grits. If you can see, it's very tiny but not much. Obviously we'll have a lot more of grits and it will be very heavy as usual. I have not created the grids here, but I do have small debris and the large fractures, the materials, the dust flowing out of the debris. Okay, so everything combined and merged is how we do RBD. It's not a single FX. Okay, there are a lot of layers to it, as I've explained, and we when merge everything together, it feels that the destruction is too powerful. Okay, not only single fractures can help you make the simulation powerful, and obviously the scale of the destruction matters, right? How big the simulation is, how big your building is, the wall is. Okay, you cannot fracture a building in 2 meters or 3 meters. Okay, it's way too small for a destruction of a building. You'll obviously have to have a normal real life scale, somewhat real life, not completely. And obviously, there are a lot of ways to cheat, from camera angles and to the forces and everything. But always make sure that a scale is too good, because the scale is what gives away the simulation as fake. Okay, if you don't have a good scale, your simulation would not look that good. Okay, so you'll have to make sure that your grids and everything is on proper scaling. If I see the scale of this simulation, it's almost 8 to 10 meters, 5 to 8 meters. Okay, from like my this whatever this box is, it is almost approximately 2 to 3 meters. If I hide this, yeah, somewhat like 1 to 2 meters, not even 3 meters. Okay, if I see, yeah, 2 meters max. Okay, I can see it goes from 2 to 2. It shows here -2 and 2. So it's roughly 2 meters. It's still too big for a slab, cement slab or whatever this is. 2 meters, it's too huge. But yeah, you always have to take care of your scale. Always understand how your scale is and then start working on it. Okay. So let's start with the RBD. First of all, I have this normal box. I'll hide everything else. Okay, I'll hide everything else. This is my normal box that I've taken. Normal box to 0.2 3 by 3. Okay, it has nothing. Basic scale. Divisions also 2 by 2. Firstly, if you want to have textures in your RBD, first thing that we'll do is do a unwrap, UV unwrap. Okay, so this will have a UV unwrap around your box like this, and then we'll place a material node here where we put the material that we want to like add to that slab or box or whatever it is. Obviously, if you have different objects, for example, here only we have one box, but what if you have different fences, different box, different slabs? So you will have to do all of this to that also. Okay, similarly unwrap and then material. This is a material that I have downloaded from Megascans. Okay, I have this here in my materials tab. One is sky and other is also sky. Okay, wow. Here, this is my material. Okay, this is a material. So I've added a material here. Now I want to fracture it. Obviously, we'll need a fracture when we do some RBD simulations. Okay, I'll disable this and also disable this. I'll go to Voronoi fracture. This is a node that we use for fracturing. Okay, it's called Voronoi fracture. If you press tab and type Voronoi fracture, you'll get a node which is Voronoi fracture. Okay, it's the same. It has two inputs and it says it requires geometry to fracture, which in case is this my geometry, and other it needs Voronoi cells, basically points. Okay, so the concept of fracturing is that wherever your point exists, it will take the in between of that points and make a fracture there. Okay, so the most basic way of doing a point is scatter. I'll place a scatter, okay, something like this. So it will scatter whatever points I want. For example, I here have 1,000 points, so it will scatter 1,000 points on my object. Okay, something like this, and I'll do a fracture. Now you can see that I do have fractures here, a lot of fractures, which is basically 1,000. And if I do exploded view, it's a node called exploded view. which can show me in exploded view, as the name suggests, that how many points do I have and how does it look. Okay, so this is how you look at your fractured points, and this is how it looks, fractured points. Okay, so now one problem that we face is that whatever scatter I did, it is only scattering on the outsides of the box that we created, or any object that we will take. It is only creating points on the outside of it. See, the like interiors are blank. There are not a single point in the interior of this box. So how do we fix this thing? We'll simply take a ISO offset. Okay, what ISO offset does it creates a volume of that box or whatever object you are taking, and obviously if you are taking a volume, it will be filled inside also, right? It is filled inside also. So now if I do a scatter, you can see I also have interior points now. Previously it was blank. If I will disable this node, see, it was blank, right? But as soon as I have created it as a volume, it is creating a scatter. Now we have interior points also, and now we fracture it, it will have interior fractures also. Okay, like the interiors of the box will also be fractured basically. If I did not do the offset, see, you can see the difference. Okay, we do not have the interior. If I disable the ISO offset, okay, if you can see through the wireframes, it is very complicated wireframe, but yeah, okay. So this was my basic fracturing. Now how do I control this fracture? How many points do I want, or where do I want it, and stuff like that. So there's no option to control how many fractures you want in the Voronoi tab. Okay, there is none. The only important thing is that you have a name attribute and you have an interior and exterior group, which is important. Okay, this will understand it later here, like why it is important. But the important thing is the name attribute and the interior group, not even exterior, interior group and the name attribute. Okay, so the number of points of fractures that you want to control is through this scatter only. If I do 100 points, it will be scattered 100 points. If I do 10, you can literally count, it is only 10 points fractures. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, only 10 points. If I do 5, you can count, it's only 5 fractures. 1, 2, 3, 4, 5. Okay, so I'll do 1000 as basics as it was. Now I have 1000 fractures here, meaning I have 1000 fracture points. Okay, so what I've done here is I have taken another ISO offset from this, and I have done a scatter with 5000 points, more points, and I've done a Voronoi fracture, so I get that small fractures, more smaller fractures. Okay, it is calculating because it is heavy. Let it do it. Okay, it's too much heavy. I don't know why, because I have another file and simulation going on the other file, so it's heavy. Yeah, it's done. So now I have a lot of points, a lot of fractures. Too detailed, too small. Okay, if I do exploded view again, now we can see we have small chunks, we have bigger chunks and random chunks, but this is not the way to do it. This is a basic technique that I've shown it to you, but this is not exactly how we do the smaller fracture. Okay, this is just for your understanding if you want to do it, and please don't do it on my values, your 5000 and 1000. Do it on your own hardware, on your own capacity, how much hardware you have and what it can take, because this is too heavy. 5000 points is too heavy. Now if I see, I have literally 2,66,000 points here, which is too much. Not too much, but for points and this debris, it is still a higher value. Okay, so don't exactly copy these values. Please have caution and change this value. But yeah, now I have here, there's a difference. There's only bigger chunks randomly, but when I get a smaller value, I have bigger chunks and smaller chunks, and I have randomly placed things. So I have both. Okay. Now, how do I use it in simulations, and how do we proceed with it? Okay, how do we fracture it? How do we break it? Things like that. Now let me like disable all of this stuff, which is RBD cluster and interior RBD. Okay, and also let it be. Okay, no problem. So now I'm in Voronoi fracture. I will delete all of this, not delete, but basically disable it because I'm trying to explain it through a walkthrough. Okay, so I'll disable all 2 to 3 nodes that I have took here. Let's go to DOP network. I'll take a DOP network because obviously I want a simulation to be happening. I'll go to a DOP network. I'll go inside. Let me hide all of this again. Why is it showing? Okay, never mind. And I'll also disable this nodes. Now, if I play this, for example, okay, before playing this, let me tell you how did we do. So basically, there are only 3 nodes that we need to take for RBD. Okay, first is this rigid body solver. Second is this object, and this is also something that we don't use, and a gravity. Okay, if I place it here again, I'll take a gravity, RBD packed object, and rigid body solver. I'll connect the rigid body solver to gravity. Obviously, I'll need a outsource output. So this is the end of it, but I'll take this output only. There's a difference between rigid body solver and bullet solver and a RBD solver. There are 3 solvers if you see. RBD solver is the oldest solver. So we usually don't use it anymore. So either it's rigid body solver or bullet solver. This bullet solver is just a HDA, a digital asset for rigid body solver. The main solver is this rigid body solver. If I go inside of this, it is using a lot of stuff that you can obviously explore. There's a multi solver, then there's bullet solver, static solver, and RBD solver, basically everything that we're using. Okay, and this bullet solver is just a default asset that you can just place it and use it, but the main solver is this rigid body solvers. Okay, this for quick iterations if you want, but this will give you more controls over things. Okay, and obviously you can also add post solvings and everything. So it's better that you make habit of using this rigid body solver rather than RBD like bullet solver. This is also good for quick results. I'm not saying that you should not use this, but this RBD solver is not usable. You can still use it as obviously, but yeah, for the benefit of speed, you should start using this solvers, which is RBD bullet solver and rigid body solvers. Okay, this is just a wrapper asset, as I said, and the main original solver is this RBD solver. Okay, so we'll work with RBD like rigid body solvers. Firstly, I'll take a RBD object. Okay, this is where I will call this whatever this grid is that I've used. Okay, so let's go to DOP network again, RBD, and if I place it here in the first context, which is called objects here in rigid body, I have a sphere by default because in the saw path, this is where I will put my objects that I want to fracture. I'll take this out. I can either call it from here, like what was the name, out RBD, I guess. Yes, so it's here. Okay, or else you can just type it here, out RBD. Okay, why did it not come out RBD? Okay, or this way. So always make a habit of putting a null, because what it will do is it will help you when you're contexting this into something else, right? For example, if I'm calling this here, right here, if you would have not named this, for example, this would be my last node, which is called transform, and I don't have a RBD out null. Okay, and I want to put this, like put that one here, and if I search for it, where do I find it? Where's my transform one? Is this the one that I'm using? Or if I do have another transform, is that the one that I'm using? It will be very confusing. okay, like which object to exactly pick. So it is better that you put a null, because we put characters there and it will come in the top first of all, and you'll know what exactly is the out of that particular thread. Okay, so this, it's out RBD because I have a null here, and hence it will be easy for me to like call the particular thing here. If I go to the top, I already have out, and I'll do out RBD, and as soon as I click the out RBD, it's here, the out RBD is here. Okay, and if I play this, now let's play it on default. If I play this, as usual, it will go down because we don't have a collision, we don't have a ground. I'll take a ground here, ground plane, and obviously I'll have to merge it. Okay, rigid body solver, ground plane and object. Please make sure if your nodes look like this, like crossed, always put the ground plane first. Okay, the simulation works with left to right inputs. The left one is calculated first and then the right one. So either on the merge you can press shift or R, or you can also shift it from here like this, but make sure your node looks like this, left to right. Okay, otherwise it won't work. So now I have a ground, and if I play it, okay, it's nothing, like it is colliding but nothing is breaking, nothing is fractured. Okay, because there's a reason it is not happening. Houdini is calculating all of these fractures as a one single object. Okay, because imagine if we are working in a large scale destruction, you're fracturing all the buildings, all the environment, all the scene that you have, and it's not just one building, it's just 2, 3, 5, 10, whatever buildings. Okay, so it's going to be very heavy very soon, because imagine a lot of constraints, clusters, we'll talk about that later, but all the fractures, all the details that we'll do, it will be very heavy. Even though you will have a good system or we are working in a studio, it is going to be very heavy. So for that, what it does is, by default, Houdini will try to pack these objects. Okay, or else we'll have to pack it that the fractures are not heavy. Okay, so here what it is doing, it through this RBD object, it is taking the complete object as one. It does not know that the grid has any fractures or any other points that we need to fracture here. We'll have to tell that to Houdini that the fracture points are different, the grid is different. Okay, now the question is, how do we exactly do that? Like on what factors, on what basis Houdini does understand that there are different fractures or there are different points? Okay, for example, let me take a single pack here, a single pack node. Okay, and I'll pack it here. Okay, and it's just normally packed. Let's go inside and let's try to again rerun this. If it works, it won't work because same, it is using the complete object as one single object. In pack, there's an operation which is called name attribute. Okay, if I on that, the name attribute, now let's go inside the attribute, the solver, and we break this RBD object. Anyway is not gonna take this name attribute. Okay, the name attribute is important. If you recall, I told you about this name attribute here, piece. Okay, basically what Houdini is doing, that it is creating the fractures and it is naming all the fractures as piece. If I go here in my primitives, you can see we have piece attributes here. Name is called piece 0, piece 1, 2, 3, 4, 5, 6, and everything. So basically what Houdini is doing, it is naming those pieces. Okay, and now I have to call that pieces, so Houdini knows that I have different pieces here which needs to be fractured, and this grid is not a single object. Hope this is making sense to everyone. Do you understand what I am talking about here? Please say yes. Okay, so instead of using this RBD object we use for a one single value that we don't want to fracture or don't want to do much with it. The second thing that we use is RBD packed object. It's the same, but it is for packed objects. As I said, that will be packing the objects and creating it into a single point. I'll explain to you how it works. Like, don't be intimidated that it is not understood or what is it talking about. I'll explain it to you again. But just remember that we have a name attribute which is called piece, and piece basically means all the different pieces or fractures that I have here. Okay, that is the only sense. So now we are gonna use this piece, this name attribute, to tell Houdini that this grid is not a single object, we have different fractures here. Okay, now I'll delete this pack that I took here, pack delete. I'll first of all go inside DOP network, and I'll put this RBD packed object into the first node, and same thing, we'll call the out RBD here. It's here. Same, if I work it, it's not working because it expects us to make a pack attribute. Now again, let's see if I take a pack here. Okay, name attribute, sorry. Okay, it's calculating very heavily. So I'll just do the RBD one. This is getting heavy. Wait. Okay, forget about pack. We'll use a assemble. This is a RBD pack. Okay, by pack, what I mean is that we have different fractures here. Right, there are 2,66,000 points, which obviously was heavy when you see here. Okay, it wasn't calculating because it was getting very heavy. We'll use a assemble node. Now if I press info, you can see points are very less. Okay, because we took the points and created one single point out of the fractures. To make it make sense, let me show it to you. Here I know that I have 1000 points, and here I know that I have 5000 points. Okay, if I assemble it, it will basically create only those points with the use of name attribute that I have here. And now if I like do the fracture, obviously it's gonna be heavy, so I will have to lower the fracture points so it does not get heavy in the real time. Let me lower the values to maybe 100 and this to 200. Okay, so it's not heavy. Now we have the fracturing. Okay, now Houdini knows that we have different fractures which are named as piece, and now Houdini is calculating that piece attribute. Okay, how are we exactly calculating the piece attribute? If I go to assemble, here I can see there are options which is called name attribute, pack primitives, edges, and all of this info. The only important thing, first of all, you need to know is that you'll have to create a packed attribute. You'll have to pack it, meaning that you have to combine all the points, okay, and make it a one object, and then differentiate it with this name attribute. But this is not on right now because we already have a name attribute here. Right, I told you about this name attribute which is called piece. So Houdini knows that we do have a piece attribute, but if you overwrite it from here, for example, create name attribute is on from here, it will overwrite all the information from the above. Okay, it will create and overwrite the values of piece attribute. Hoping that it makes sense to you guys. Right, so we don't want that because we already do have a piece attribute here. Okay, so hence will not reset or overwrite the values of name attribute. So we are just turning off this name attribute. We'll just create a pack primitives and just go inside, and it is fracturing everything. Right, as soon as it collides with the ground, everything is been fractured. But this does not look good, right? Because in real life, this is not how fracturing is done. If you are breaking a wall or you are breaking anything, this is not how it breaks, that all the points or all the fractures are completely shattered, right? Except for glass, right? Glass is a different thing, but for wood, cement or anything like that, it's not that everything will be just shattered. Okay, there will be chunks that is still there, which is not broken, or it's lingering with some small points or big points, right? So we'll have to do the similar thing in RBD here. And now how do we do it? First of all, just write it in the comments that I've understood all this packed primitives and basics of RBD, like how do we put the nodes, what exactly it is, how do we fracture. Is it clear to you guys? Just let me know in the comments, so then I can move forward with the other stuff. Was it clear? Okay, so now same, will move forward. Okay, so the concept that we talked about, that obviously when something falls or something breaks, it does not get completely like shattered, and there are chunks that is still there intact and not broken, or will be broke later after some force is added. So those kind of things, in RBD terms we call it as clusters. Okay, it's a term called cluster that we are gonna use and we're gonna add. Here I do already have a node which is called RBD cluster. Okay, if I just turn it on and I can visualize this one, this is my clusters. Okay, basically what clusters will do is, this was my fracture here. Fracture had too many points. Okay, something like this. So what cluster does is, it will, I'll just like default this. Cluster will basically group different fracture points and create one fracture. Okay, that's the basic concept. If you see this color, this green part, this is one fracture, this orange is one fracture, this violet or magenta is one fracture, this violet is one fracture, blue is one fracture. But if you see fractures, these are different points. But when I do clusters, this one portion, this one color that you see is one fracture. Okay, now when I break this cluster by default, okay, you will see that only this clusters are breaking, not the individual fractures. Let's directly go to DOP network and we'll just play this. Now we can see that there's a hell lot of difference in both the fractures. Firstly, the fractures are not shattering, right? It is in groups. Obviously it depends upon the kind of force that you're adding. Now it's just a basic gravity. So as per gravity, when it is falling, it is falling in chunks and breaking in chunks, and obviously there are small particles that have gone through and broken. But now we don't have that shattering kind of thing in RBD, which is basically this is how we want. Okay, not like that it is breaking completely. This depends upon your force also. If I do a velocity -15, because it is going in down level, so it's -15 of force added. Okay, so it's gonna be more hyper, and then it's gonna break more because we are adding more force to it. But if it did not have a force, it's just basic gravity, it will break normally. Okay, so this is achieved through clusters. Now if you think that the clusters are too much and the grouping is too much, you can obviously control this here in the RBD cluster node size. The lower you do, the more the clusters there will be. Okay, and if I go it again and do a cluster, now I will have more cluster points. Okay, this is different from the normal fracture. The fracturing was completely shattering all the points, but this is clusters that is breaking. Same, cluster is also a name attribute. Okay, if you see, it's also a name attribute. So please make sure that the name attribute here is not turned on. If I turn it on and if I do the simulation, everything is breaking again. Okay, because here if you see in assemble, the name attribute that it is overwriting is called piece. So we do already have a piece here. So Houdini is now telling that this piece attribute is basically every point fracture. So just fracture it everything. Okay, it is not using the cluster name attribute. So make sure that you are not overwriting the name attribute. And now as I turn this off, it will use the cluster name. And again, if I check, my clusters are working fine. Okay, hope this makes sense. All right, so this was the basics. And now if I want to add interior details on it, what about interior details? There's a node which is called interior details. I can check this interior details again. If I do the exploded view here, I'll just turn off this cluster. Okay, first of all, let's see the cluster, how it look. Okay, sorry. This is clusters. This does not have any interior details or noise or whatsoever. But as soon as I put it in interior detail, I can see it does have to a limit interior details. I have not put much details here. If I did, would be heavy. Yeah, but it does have. Okay, now you can see it is turning a little noisy. Obviously, you can change the frequency of the noise. You have the amplitude of the noise, offset, what kind of noise you want, and everything that. Okay, you can obviously explore it by yourself. But this is how it's done. This is the basic detail size, how much detail you want. Obviously, don't go lower than it is required. Obviously, it will be very heavy, right? And now the most important thing that we also overlooked here is two things that I asked you to understand. First is the piece attribute, which we saw how piece attribute is working. Second was this interior group, which is called inside. It's a group called inside. Basically, it's creating a group where this inside pieces exist. Okay, if I disable this from Voronoi fracture, this inside group, both of them, this RBD interior detail won't work, because if I see it is working on the interior group, the inside group. Okay, so it is important that we have this interior group here so that the interior detail group can work. Now it is working, no complaints, right? It is working on the inside group, interior group inside. It requires this inside group, and this is also required for our material, which we'll do it later. Now that we have done the interior details, same, I'll do a unwrap and I'll do a material, but only on the interior group. See, I've only added the UVs to the interior group, and if I check the materials now, I have materials in the insides also of my RBD chunks. Okay, let me show you the difference. I'll just go to RBD detail. See, this is how it looked. It was just completely stretched and there are no materials inside. This is the stretched material of the outside, right? But if I go here, material, you can see now we have interior material also, which is perfect. I've given the same material, okay, on the interior and exterior, but obviously you can do a brick color or red color or whatever you want in the interiors. And I've done this UV first of all in the inside group. This is just one of the techniques or methods that I use for basics if I want quick results and quick movement. Okay, so this is how I do it. It is very easy, but obviously this is not the perfect technique to use, let me tell you that. Okay, there are a lot of ways, lot of techniques that we can create interior details or interior fractures or material like this, but this is one of the technique that is easy for beginners. And when you try to create some fractures or points, this is one point that I've seen that there are no tutorials available for this, and there is no clarity how to exactly material the interiors and exteriors of the fractures, and how to take it to the renders and render it with interior and exterior materials. So this is the basic way of doing that. Okay, I hope you understand and utilize this in your fractures, but this is one way. Okay, so now we have textures in both interior and exteriors. Okay, and I have done a transform obviously, so I want the fractures to be above, and when it falls with a force. I am not using RBD material fracture because same, it is a asset, it is a digital asset which is called HDA, and it is too heavy. Okay, if I place it, you can see there's a lot of calculation, and if you control this with materials, it is easy, no doubt it is easy, but there is a lot of unnecessary data which is being calculated that I don't need at all. Even if you are not using all of this, it is still being calculated in the background, and it is way heavier and slower to use to fractures or anything like that. So I do not prefer using all this HDAs, and as a beginner you should also not do it, because it's very easy to understand or do fracturing from here, that everything it has values here. Just have to change the values, add basic geometry, and you'll have the constraints, you'll have the fractures, you'll have all the details and everything, but you'll exactly not understand what is being worked, what is working, what is not working, what is required, what is not required. I am doing exactly the same thing which RBD material fracture does here with DOP network in basic 3 nodes. Okay, gravity, rigid body solver, and packed object. If I go to this rigid body also, insights, there's a DOP network here. Where is it? This is guide geometry. There will be a DOP network here which is using the same node that I'm using. Yeah, I'm not finding it here. But you can see it's the same RBD pack that we are using, and there's a loop, there's constraints, there's RBD unpack in the end which will also do constraint properties. Basically it's using the same DOP level network. Okay, so we don't want this to be too heavy. As a beginner, I would not suggest you to use all of this solvers unless you want quick results obviously, but if you are doing it for understanding, for the basics, for the purpose of understanding Houdini, you should not use all the SOP levels solvers. For example, Pyro solver. Okay, this is also solver which is available on the SOP level, but I personally don't use it because it's just too unnecessary data that we don't require. Okay, and it's the same thing that we use in DOP. See, it also has a DOP level, and it is using a Pyro solver, it is using a smoke object, it is using a collider. It is the same thing, it's just a asset, a default value that has been given. Okay, so just don't use it because it's just unnecessary. We can do it here easily. Okay, hope it made sense. So now if I obviously calculate, everything is fine and working. I do have the interior details, I do have the fracturing, I have everything. Okay, now we'll talk about constraints. Okay, what exactly are constraints, and how to use it and why to use it. For example, here also, even though all the fracture points are not fracturing and now we have clusters and everything is breaking in a group, this is still not exactly how RBD or any fractures or any destruction is happening in the real life. Not everything shatters all at once. Okay, if you see, the impact breaks first, where the impact is, and then some chunks will remain unless more force is applied, right? For that we'll use constraints, that everything when it collides to some object or force is added, it does not fracture all at once. Okay, unless there is a secondary force that is being applied. Okay, we want that the object needs to be in a closed circuit, we need to hold it together unless some forces or any collisions are happening. We need to hold it together, right? For that we'll be using constraints. Okay, how do we proceed with constraints? What exactly it is, right? From this transform, not from assemble. You can also do it from assemble, but I like to prefer it doing above the assemble. Take a node which is called connect adjacent pieces, like this. Okay, by default it will be on points. Will not use it on points, we'll use it on primitives, because we want all the clusters to be held together, not the points. This is good if you are working with metal bending, but we don't want this. We want fracturing, right? So we'll do a adjacent pieces from surface points. Okay, all of this technique that I am showing it to you, this is the uh, default or manual work of working. If you don't want this to do, there's also a RBD constraint property, or which will give you the same values, strength, glue, or whatever that we'll be talking about. But obviously, same. These are all the HDAs that is being created from this only. So why not use this basic thing, right, for understanding, and you understand it better, and then you can use it later when you're not comfortable with the subject, right? So we'll take a connect adjacent pieces. Now, as soon as I've done adjacent pieces from surface point, we can see a web-like structure here, which is basically holding my clusters. If you can see, it is holding the clusters. Okay, same logic here. It is creating points in between and taking the uh, what you say, the in between point data, like where it exists, and it is creating clusters around that. So basically, it is holding all my clusters together. Okay, this is how it should look usually. But default, majority of the times the clusters will be fine unless you have any open geometry, or the geometry is not good, or the source is not good. You'll have issues with the constraint, but majority of the times your constraint will look fine. How do I know if the constraint is looking fine? This is how it should look, that it is comprising of all your data, all your geometries, and it is holding it together. Okay, by seeing this I can see that it is going to the far edges, and it is holding everything together, and it is fine for me. Okay, don't try to unnecessarily create more points here, because the more points you give, the more stronger the constraints will be, and hence you'll require more force for it to be like broken. Okay, it will not be easy for it to break. So unnecessarily, please don't increase the points or max connections like this. See, it is increasing the constraints here. We don't need it. If the default is working fine, it is fine. Okay, don't unnecessarily complicate it, or make a huge constraint. If in case your constraints are not proper, it is broken, or it is not a complete piece like this, you can try increasing the search radius, so it searches the around points that you can capture and create a primitive. Basically these are primitives. Okay, create a web basically. Or you can increase the search points or max connections. Okay, see, as soon as I increase the max connection, it is creating more connection in between these points. But if default is working fine, it should be fine. Same, it is working on a name attribute. See, so the name attribute is very important in RBD. Right now we have created a constraint, but Houdini does not know what exactly to do with this. Okay, what exactly to do, how to hold, what is exactly this constraint doing, and all of that shit. So I will have to create an attribute triangle, writing a basic name attribute, a string basically, that says this constraint is a glue. This is a glue constraint. Okay, imagine glue holding together everything, a normal glue. Okay, it's the same logical thing, that it is a glue which is holding all the pieces together. So what I've written here is, I have a constraint name which basically Houdini knows. Okay, a constraint name which is a glue. Houdini knows all of this. I just have to place it here, that this is a string. String meaning it's a name, just a name. Okay, what name? I'm giving it a attribute which is a constraint name, and the string is known as glue. Basically the value is glue. If you can see here, the attribute is called constraint name, and the string glue basically is the value, a name. Okay, This is not a 1 2 3 4 5 kind of value, it's a name value, string, right? I have written a string here. S stands for string, at the rate because I'm calling some attribute or creating an attribute. Here it is name constraint name, so you can see there's a constraint name. Now every primitive, basically these are primitives, so we'll work on primitives. This is not points, okay, primitives, because these are lines, right? So these are primitives. Now every primitive has a glue value, okay. Now Houdini is fine with it, and it's like, okay, now we have a glue constraint. I'll put a null again because I know that my constraints are over. Out constraints. We'll go to DOP network again. Now how do we place the constraints here? If I play it, it's the same, there's no difference, okay. I will take two nodes that will help me understand and get the constraints, okay. First is constraint network. I'll place it below this rigid body solver. I'll connect this, it will get automatically connected in the first input, but still it's angry because it needs the path where the constraint exists. So I'll just search for it. It's called out constraints. So I have given it the path, but it still is arguing that something is not right, because it is showing you that you need constraints to create what exact constraints you want. I know in this case that we want a glue constraint. Okay, if you see, there are a lot of constraints. Okay, there's like the vellum constraints for the vellum. There's spring constraints, there soft constraint, hard constraint, wire constraint, and glue constraint. There are a lot of constraints, but here the base, like most basic constraint that we use is glue. Now the glue constraint is here. It is not arguing anymore. It's not angry. But if I play, it will not work. Okay, the most default thing that you can do is to check if your constraints are working or it's being called here or not, is to go to rigid body, this display geometry, you can off it and see if the constraints are there. It's not there, it's not coming only the constraint. I should see here exactly. So the reason for it not being available here is this name in the glue constraint name. Remember, we gave a name which is just named glue. You can give any name here. If I type Arjun, it's not like that I have to name it glue only, but just for reference, just for understanding, I place it glue. It needs to have the same name here, Arjun. Now I can see that I do have the constraint visible here. Okay, I have the constraint visible here, and now I know that my constraints are working. It is now imported into the the DOP level. It should look exactly like how it is looking outside. Okay, same. So now if I play this, you can see it is breaking and it is staying, obviously, because force. Now we'll see the same with geometry, how it looks with the geometry. If I play this, perfect, the constraints are working very fine. How do I know it's working fine? See, constraints are only breaking when there is force. This was my first force that broke my constraints and the fracturing happened. Everything else is intact, but as soon as it like collides again, there's another force here. See, all of this is not colliding, only the edge was colliding first. It breaks again, and now the force is not enough to break all of this, so it just stays there. But my constraints are working very fine, right? So now I do have the fracturing, I have the cluster points also, and now I have constraints which is also working, where force is much, only the constraints are breaking there, and the rest of it is just there. So how do I control how strong the force is or how strong the glue is? Basically, if in glue constraint, you can see there's a strength. If I put 4000, maybe the strength, and play it again, you can see there's a difference. Now, first impact was the same almost, that it had an impact. Second impact, the force was too low, the constraints were too low, the strength, so it broke, right? And if I did 1000, it's gonna break everything. See, okay, because it's based on the term energy. Okay, energy is spread throughout when a force is applied. If it is interacted with one thing, for example, this grid is being interacted with this collision, the ground plane, the energy is exerted throughout the ground. Okay, so at this first impact, it is having a good strength of 1000. It is holding back everything because this basic impact took all the energy, all the force. But as soon as it collides again, it does not have the energy to hold the constraints because we only have the strength of 1000. So it is breaking everything. Okay, what if I did 1000? It was the same that we saw. Okay, it still holds back because it has the value and the force has not traveled to these constraints. What if I did it 15,000? Okay, same with force 25,000. Let's say with 25,000. You see, there is less and less breaking now because the constraints are holding the strength of 25,000. So it's not easy to break unless we add more force to it. For example, same if I do a minus 15 velocity and now I will break this, you'll see it is breaking more because we do have a force that is breaking the energy, the strength of the glue. Still not enough. Let me do it 25. See, now it is breaking the constraint, even though it is strong here. It all depends upon force, what the force is, how strong the force is, and how it is holding it together. So this is interrelated, the force and the constraint strength. Let's put it to default 1000 and this also to 0, and everything is perfect. Was this interesting and amazing? Did you guys like it? Comments में बताओ अच्छा लगा क्या? Did you guys enjoy this? Was it exciting? Yes, do you guys want a break? Small break? Or you guys want me to continue? Okay, we'll take a 5-minute break and we can continue it because we now have creating debris and then dust from it. So it's a small process, not much. And obviously, if you guys haven't subscribed to the channel, please do so. Like the video and share it to your friends. It will help me. Hello. Yeah, okay, guys. So, hoping that you guys are back on the break. So, we'll start with the further process. If you guys are here. Okay. So, let's begin with the debris part, and then we'll take that debris as a source for our dust, and we'll create something like this. Okay. For example, if I click here in the DOP network, and we'll see there's nothing right now. Okay, by default it should be, but it is nothing right now, because in the DOP network, by default, if you see, there's a star here in the object, and if I play like again, we'll see everything is here. For example, my fracturing is also here, the grid is also here, the ground is also here. I don't want all of this, and I will delete this part now. It's not required, the older part that I was using. Sorry, the newer part that I was using. I'll delete this. I'll take my own setup here, which is the same. I've done nothing new. It is the same. Okay. I'll on this constraint networks, and the glue was on the strength of 4400. This is something that I'll explain to you later. And I was using a static source. Okay, this will also understand later why I was using this. But if spoiler alert, I'll tell you that we were using this as a collision, because if you see, I am not colliding it on a ground. I'm colliding onto this object that I was using, a mountain perhaps, right? So I have taken that mountain as a collision here. That's the only difference. Okay, there's nothing new. So I've taken this mountain as a collision here, and I'm colliding like it with the mountain. That's the only difference. Okay, see this one. Now in the DOP network, when you visualize this from here, everything is here because it's on star. But I don't need everything, the ground and other fractures or other objects. I just need the RBD object that was breaking. So what I can do is I'll just take the RBD object and remove the star first. Okay. So now only the RBD object is here, right? So we do not have other objects here. We just have the RBD here, and it's fracturing and perfect. Okay. Obviously it is going below the ground, but here we have the camera angle in such a way that we do not see the portion where it is going below the ground. Okay, if I show it with the camera, it does not uh, is in the frame where it is going in like below the ground, right? So obviously you'll have to tweak it in such a manner that you are not unnecessarily creating your simulations huge or making the collisions higher, that it is colliding way above or aside from the camera angles. It is fine if the camera angle is in such a way, and it is going below the ground after this camera angle, it's fine. Okay, for example, here it is going down, but it is not visible. I don't care about it, right? Like this was my camera angle. So first thing first, we'll do a caching on disk, so it is not heavy on my software here. I'll do a simulation on my system. I'll save it there, so it's easy for me to use it. Now this is my the other what we say fracturing. Okay, where I have 5,000 points and the detail were too high, if you can see, and there are more fractures. Because I'm reading the cache, I had already cached it, so this is looking like this, or else my normal DOP network was like this, right? Because I had lowered the fracturing point from here 200, but it was 5,000 and this was 1,000, right? So this is how it looked, okay, with the detail and fractures. So obviously you can go to this detail if your computer allows you to, or else please don't try it, it will crash. Okay. So now I have this. I will immediately only take a debris source. It is a node called debris source. This is only available in 19 and above versions. 18.5 and 18 does not have this. We'll have to create it manually. Okay, let it read it. Let's go to the first frame. Debris. Okay, never mind. I'll show it to you again because there are portions that I need to show it to you. I'll take a debris source here. Okay, this is my debris source. And as you can see, it is creating some points on all the objects on all the geometry. And if I play it, as soon as it fractures, you can see it is changing colors, and it kind of gives a feeling that it is dying at the end. Okay, that it is deleting the debris, but still it exists and it is on everything. Now imagine if I take this as a source in my dust simulation, this portion will also emit dust. Okay, if I show it to you right away, I'll connect this Pyro Source that I was using, and here, is it working? Yeah, you can see this is kind of creating a fuzz that I don't want, because it is using all the object and all the points as a source. See, too much. I only want the fractured points to emit dust, right? So let me do it again. Oh, sorry. Yeah, fine. So let me explain it to you how this works, the debris source. First is your rest frame. This is the first frame that you're working. Okay, minus 1001. Cache memory normal, how much cache you want to read from here. Okay, this is currently using 5 GBs or RAM. So as soon as my 5 GBs is filled, it will start deleting my caches from the RAM. Density scale, basically scatter how many points or density you want from this debris. Now it's 1000. If I do it 100, it will be less. If I do it 10, it will be lesser, right? So this is the density scale, how much dense you want a debris or source to be. Okay, same, there's a max point. It will not go above this level. Okay, even if you, for example, if my limit was 10,000 and I give it 1 lakhs, it will not happen. Okay, it is just giving me 3 points because I am above my max point level. Okay, I only have 10,000 limit and I'm going way above the limit, which is 1 lakh. If I did it 10,000, it would have been there, but it's not working in this case. Okay, let's just put it on 1000 and default to 1 lakhs or whatever this is. Distance is the distance between all of this. This will not make sense right now, but if I show it to you, increase, yeah, this will not make sense right now. So let's leave it to default because this is the release value. It will make sense later. I will show it to you. Third is the age and lifespan. As every particle has a age and it has a lifespan, like when it was born, when did it die, things like that. Okay, so this is based on age attribute. If you know how particles work, it does have an age attribute in particles also, like the lifespan, the life variance, and things like that. Okay, the lifespan is basically 1. And now let's see, by default it was like this, that it is spawning and it is dying. Okay, but what if I don't want my entire object to be used as a debris source? I just want when it collides, it should emit debris. So below at the bottom, there's an option called remove unreleased. As soon as I click this, the entire object is gone. And now if I play it again, it only creates debris when it is colliding at the ground. Okay, it is not creating it on the entire object. It now only has the colliding points. Okay, so the first issue that I had, we have solved it. Okay, which is this unreleased. Now the lifespan. This color ramp is the lifespan, meaning yellow is the newly spawned, new life, newborn thing, and the violet or black thing is the death of the particle. Okay, basically it is dying, right? So this depends upon your age, lifespan here. If I do it 0.1, as soon as it spawns, it is dying quickly. It's just quick. And same if I do it 2, its choice longer, that it is dying very slowly. This will make sense when you start doing dust simulations, okay, or else it won't. So let me do a dust simulation. Okay, this is my debris source. I'll do a pyro source now because I need to create a source which is just density. Okay, I'll just do a density here. Obviously this is not a pyro lecture, so I won't be covering all of this, what are the values, what are the things and stuff like that. Okay, this is basic, that I've created density attribute which is used for smoke. Okay, this is not used for fire. Density meaning it's a smoke, it's a volume. Anything volume in Houdini is smoke. That is how I like to think about it. Okay, so density is basically just smoke, and obviously dust is only smoke. So we just need one value, one attribute, which is called density. Okay, and we have density. Now if I play it, nothing's happening because I need to rasterize this. So I will take a volume rasterize attribute. I need to convert this attribute to a volume. Attributes, I'll take density. Now you can see that I have this density which is very blobby, very bad. So I can decrease the particle scale like this. So it is a less blobby, maybe more 1.5. So now you can imagine that how my dust would look. Okay, this is how my dust is looking. Obviously it needs a simulation, but this is how it looks. Okay, now the problem is that, okay, before discussing the problem, let's take a DOP network. DOP network, and don't want to connect it. I will just take a null here because I like to keep it categorized. Debris source. Oh, spelling of debris. Debris. Okay, debris source. So this is my out source. I'll just go inside the DOP network. Simply create a smoke solver because I'm working only in smoke, and object, a volume source, and a smoke object. Okay, these are the three things that is required for any simulation. Object, a solver, a source. Okay, in the source I know that my source is called out out what was it, out debris source. Okay, I'll just copy paste this here, path, and I have a smoke solver. Everything is normal. Let's see if it works. By default it won't because I haven't given any density attribute here, so I just need to do a density, take density and put it to density. Let's see if it works now. It is to some extent. If you see, it is doing something. You like, basically I know it is doing something. But let me take a gas resize fluid dynamic. What this will do is that it will rebound this bounce according to my source, or else easy way is enlarging this if it works. Yes, it is working by default. Obviously, see, the points are going below the ground, so it is creating the source continuously. So let's take a ground plane. Same, because we need a collision at the bottom. Okay, now I have a ground, and now you can see that it is colliding to the ground. Or is it not? It is, but some are colliding through because the voxels are not perfect, and the grid and the source is also below the ground also. If you can see, it is below the ground too, so it is going below. So maybe I have to lower my ground position minus 0.2, minus 0.5, bit more, minus 0.6. Okay, now it won't go below the ground. Yeah, it isn't. It is still okay. It could be because of the voxels. Never mind. Gas resize. This will increase or bounds according to the smoke. Okay, so I'm just clamping this grounds. I do have the source and smoke. Now the main problem is that even though the dust is over and debris source is over, it is still emitting smoke. It's not dissipating, or it is not uh, basically going off, right? If you can see here from the source, it still exists, the source. It is still there. I don't want this. I just want that the debris is just putting the particles out and it is dying completely. So in the debris source, I have another option which is called remove at life end. So now what it will do is, as soon as the particle dies, it will remove the source, the particles only. Now if you can see, the source is also dying. Okay, now I do not have the source lingering around. It is dead. There are some of the particles here which will also create an issue. I'll show you. It will still emit from that point. See, the particles are not emitting, but it is still there. It's continuously emitting. I don't want this. Now, this unreleased and age factor will make sense to you. Let's check. Okay, this is dying at this point. Now, let me reduce the lifespan to 0.5. You can see the lifespan of the debris is reduced, maybe more. So it is going, but not completely. Now, how do I tackle this more? Like, how do I have more control over this? Like, what exactly and how and where the debris are sourcing, and exactly things like that. There's a third option in post process which is called speed threshold. Basically, this is, you are telling the source that only have this much speed, then you will emit the source, or it'll just die. Right? For example, if I do 2 here, so we are basically telling if you have the speed of 2, then only emit the points, or else don't. Now you can see it's completely gone because the source that we have here does not have a speed of 2, right? So it is deleting and it does not exist now. Even though if I remove this life end, you can see everything is just dying because it does not have a value of 2. Okay, but still we have to do this because we don't even want the points to exist. So I'm just removing all the points. Okay, even if the lifespan was 1, see, the particles are just dying because the speed is not 2 of the particles. Okay, hope it makes sense to everyone, like what exactly is happening here. Does it make sense to you? Or it feels like that I'm just blabbering? Make sense? Cool. Okay, so now I have a control over everything, that how much my debris are and how they are dying when they are dying. Now I need to do some things in DOP network. Okay, as simple as just adding a gas turbulence and dissipation will work. But instead of using this completely, I'll use velocity. Okay, velocity of what? The object that is falling. Because if I compare it right now, where do I compare it? From the previous one. Okay, let me import it. DOP import fields. I'm just importing the data outside. Okay, so don't worry what is happening. I'm just importing the data. I just want density. So I have the smoke here. This is very low res right now, so don't worry, we'll just do something about it. But I now have the smoke, and if I merge it with my sorry, RBD, I'm just fumbling the words. Where is it? From, I think here, yes, this was the cache. So I do have a source, I do have a dust from where it is exactly colliding, but you can see the impact of that dust or the debris. It is not showing into the dust, it is very flat, right? I want that velocity to be captured with the force of this debris. I want the velocity to move my dust, right? Because velocity is a force. Obviously, if something collides like this and it has an impact, the dust is not this flat. It will have a source, it will have a force, sorry, that will move the dust around. Okay, I want the velocity now. So how do I take the velocity? For example, I know I can see if I press the I here that I do have a velocity here which is calculating the speed of this debris. Okay, I need to use this here. I need to rasterize this here. Okay, maybe you can do a velocity blur, and same, this is not a pyro class, so I'm not going into much detail of this. Okay, but I'm just rasterizing a like velocity again, same like density. I'll just go inside into the source. I'll add a velocity. Velocity is a vector field, v for well. Now let's see if there's any difference with this. Now you can see the smoke is moving around too fast, too quick, according to the interaction of the debris and the dust. Okay, it is not flat, right? It does have motion without any forces that I've applied. There's literally no force right now. Everything is just turned off. There's just velocity which is making this uh, force. Okay, now for breaking this, you can use a gas turbulence or a gas disturb. I don't like to use gas disturb much, but we can make use of gas disturb right now. I'll just merge both of them and put it to the third or fourth input. Everything is on default. I just turn the gas disturb from continuous to block based because it will give me blocks, small blocks. And now we have a detail and a little bit of random motion. Okay, and the sim does not continuously emit the source, the debris, and whatever is emitted is just there. Obviously it is not dissipating. We want it to dissipate, meaning we want it to disappear. So I can also put a gas dissipate here and maybe a evaporation rate of 0.9. Too high, but let's see what happens. So there's a collision. We have a smoke. It is creating velocities and then it is dying. Okay, you can see it is fading out, the smoke. This is how exactly we wanted it, that it is colliding, it is creating dust and it is fading out, right? In this case, it's happening very fine, right? If I play it again, obviously it's heavy to calculate here. We'll need to take a flip book. If I take a flip book of this, Let me play it. So you can see the velocities is working fine, the dissipation is working fine, the noise is good, and it is only the dust is only happening where it is colliding. I still see a issue here. I don't know if you can notice it. Uh, the dust is still emitting at this portion. See, even though everything is just the debris are done, it is still sourcing the debris from here and it is creating smoke. So this was the issue that you need to fix. And how do we fix it? Because it's the same, the age and the speed factor. Okay, you have to play with your values where exactly this ends. See, even though after the debris are over, there are some chunks that is still emitting the dust. See here at frame 45, 46, and if I see it here, it's the same point. See, frames 45 and 46, it is still emitting the source, so the dust is still happening there. Okay, so I also need to fix this. So maybe I can increase the speed, say 2.2, but it's still there, maybe 2.5, and lower the lifespan a bit, 0.8. Now it's gone. So it just completely ends here. Maybe I just don't want this only. I just want that all of this are gone, and I just need that part 2 also be not there. So maybe a bit more, 0.7 and 0.6. So yeah, almost gone. It's still there. Okay. 0.5, maybe. Okay, let's keep it and we'll cache it again. Let's see it again, how it looks. Now you can see the difference that it is obviously not having a source, so it is colliding faster, having the force faster, and it is dissipating quickly. Right, at this point we don't even have the smoke. It's gone. See this portion, it's just not there. I play it again. See, everything was quick. Obviously at some point, if you still want that this debris should still continue emitting the source, so you'll have to manage it with these values only. For example, even if I do have at some extent, it is not visible here. Okay, but it is there. So it's this values only that you'll have to tweak in the debris source. As your source will be, your volume rasters will have the same source for dust, and if it does have a source, it will emit dust from it. If it does not, it will not. Okay, this is your source. And obviously I do have a detailed one here if I show it to you, but this was the complete process for debris source and generation of dust from debris. And if I show it to you here, this was my debris. Okay, very quick and dissipating. Same source, I did a high-res simulation with all the collisions, because as usual I was using this mountain as my collision, so smoke will also collide with this mountain, right? So I was using that as a static object, and same cheese, dissipation, disturb, and everything else is the same. And this was how it was looking, my dust. See a little bit of detail because I had obviously a good voxel count. If I will show you, it was 0.05. Okay, so it is very detailed. So this was my smoke dissipating quickly, also having this little lingering noise, but still I was using this noise with a gas disturb. You can see it was very jittery. So this is the issue of disturbance, which is why I don't use it. If you increase the values, it will just cause jitter, but it's fine with this because it just dust. And later I do have a pyro bake which will color my dust. Pyro bake is for shading. And if I watch it together, whatever I have done, this is how it looked. These models were from Megascans. Okay, See, the mountain was too far from where I did the sim, but it's just camera angles. It helps you understand the perspective that it is close, but it is not. It is too far from it. But it's just the angles. So if I take this, so this is how it was looking. This was my play blast, and this was my sim. Hoping that the RBD part was clear to everyone, that how we did the clusters, constraints, textures, and debris source, and then dust source. Right? Hoping it made sense to everyone. The only part that we have left is the rendering one. We'll also see the renders, that how to render with motion blurs and put a basic lighting. But hoping that this portion was clear to you guys. Okay, let's move forward to rendering and lighting. For the light part, I only have a sunlight and a skylight, normal basic lights. Okay, and for the skylight, I do have a HDRI, which you can download it from the internet and use it here. Rest everything for the light is very default, literally default. I've done nothing. Okay, the light is here on values 1 and sunlight is also on 1. Now let's start rendering it. I'll go to one frame which is maybe 12, and go to out network. I have the mantra node here. By default the motion blur would be turned off, so let's just render it right away without motion blur. For the first frame it will take time because it is calculating all the objects and the data that we have, but for the second iteration it would be faster. Yep, it is rendering. We do have the dust. Okay, we do have all the objects and the fractures. Let's just wait for this to be over. This is not usually how I suggest for you to render everything together. We'll render like while working in the pipeline, we'll render everything differently. Like the RBD is differently rendered, the dust is differently rendered, the background is differently rendered. But for this example, I have rendered everything together, but this is not how we work, because if you render all of this together, you won't have that control on the comp, because this is one single object, this is one single image. If you do a grading or color grading or whatever it is, it will be completely on one single frame, right? You don't have a particular control over this RBD or this dust, so we need to render in layers, and this is not what we'll cover in this RBD session. Okay, so now this is something that does not have any motion blur, and this is still okay if you don't want motion blur, this is fine. But with motion blur, there's a different thrill that you get after seeing all this destruction shots. The only thing that you have to do is, I'll just pause it. You'll have to first allow this motion blur from here, just on the motion blur. Second would be that whatever object that you have, you'll have to go into that geo, and sampling and geometry velocity blur, you'll have to on geometry like blur, velocity blur. Okay, if you don't do this, even after doing this allow motion blur, it won't be available to you guys. So you'll have to do this from here also. So make sure you also do the geo motion blur here, whatever objects you have. And then if I do it again, the renders, it will look completely different with the motion blur. It will have that speed that gives you the notion that something is moving. See, it is already giving us a good result here. I'll just render this chunk because everything else is not moving. Even the shadows will have a velocity blur. Okay, see, there's a difference if you can see. I'll show you the comparison. Let me just render this. Only this part. Right, I'll just pause it. Now if you can see the difference for the motion blur and normal. Right, normally we didn't even know that some fractures existed here and it was breaking, but in the motion blur it can be visible that the things are breaking. See, because the fractures were moving, but in the velocity it was not visible to us. But as soon as we uh, did this motion blur, it is visible to us that it is giving us a speed visualization, right? That something is breaking, something is moving, kind of. So that's the difference between motion blur and blur. And I do have the interior textures as well and the exterior textures as well, and it is rendering completely fine with the fractures. Usually it goes black or it is very stretched, but nothing is happening here. It's just perfect. Perfect to the last minute details. Okay. Right, so this was our RBD session, which I didn't plan it to be this long. It's almost 3 hours now that I've been talking about this. So we have covered all the basics of Houdini on the very basic levels, like what are attributes, what are data types, what are the different contexts, and we have covered RBD. Literally from this, what I've taught you, you can literally fracture any building, any wall with details and with debris and dust and everything. We have literally covered everything that you need for RBD to work. Okay, and you can create good and great results from this. And hoping that you utilize this in your projects and create something good out of it. And don't forget to like tag me or send it to me on the WhatsApp or LinkedIn or wherever you upload it. I would be happy to see that you have learned something and created something out of it. And obviously, if you want more details and want to understand more, I do have a course that I run, okay, where we'll talk about all of this, but in more detail. Basically, this is literally a chunk of what I teach in the class, which I have taught you today. Okay, this is literally how we do it, obviously in a bit more detail. So if you're interested, you can text me and you can join the next batch. Okay, it's a 3 to 4 month course, and I do have a PDF for it. I usually don't, but I do have it. And these are the topics that we'll be understanding about basics of Houdini and how attributes are, how to work, what are the difference between VEX and VOP, and how to work with the data in detail. And obviously there will be particles and pyro, which is basically a fire, and then we'll do destruction and crowds and flip. Flip is the last thing that I am actually learning. I am not comfortable because it is very heavy, but we do understand what are flips. Okay, the next batch would be commencing by January end or Feb start. Okay, so if you are interested, please do text me so I can add you to the group, and then we can continue the basics and everything from scratch again. Okay, so this was it. This was the session. This was the render that I did for you guys, and I think this is it. Hopefully you liked it, you enjoyed it. Please subscribe and like, share it to your friends, and see you in the next batch or the next masterclass whenever it will be. Thank you so much. Please take care and bye bye. Yeah, one more doubt. I'm sorry. Yeah, you can ask me doubts. I'm so sorry. I didn't do the doubts. Yes, yes, yes. Karthik, what doubt do you have? Okay. Yes, guys. Do you have any doubts? So please let me know. What doubts do you have? Or else, if there's no doubt, Karthik, you can text me on WhatsApp. Okay, so we can talk there about this. I'll end this session here and we can take this forward in WhatsApp. Okay, thank you so much, guys. Bye.